Today in this video we will be discussing about previous year question paper grade 10. Exam was held in 2023 on 4th of March. So most particularly we will be discussing about chemistry questions. Okay. Heading straight to the first question. It says that in the experimental setup given below, it is observed that on passing the gas produce it in the reaction. Okay, on passing the gas produce it in the reaction. Okay, first of all, understand what gas is being produced. The reaction is hydrochloric acid is reacting with sodium carbonate, Na2CO3. This is sodium carbonate. So we know that this reaction produces NaCl two times. It also produces water. It also produces carbon dioxide, CO2. Now this one is carbon dioxide gas and it is being passed into this solution X, and solution X turns milky. We know that carbon dioxide can be tested by lime water test. So that means carbon dioxide is being uh, passed through lime water, that's calcium hydroxide. It changed into calcium carbonate, that's milky. Now if we continuously pass carbon dioxide gas through calcium carbonate in water, it produces calcium hydrogen carbonate. Okay, this one is colorless because it is soluble in water. Colorless, so milky color will change into colorless. What should be the option? The option is given to you, that's B. Here we go. Calcium hydrogen carbonate is the end product of this reaction, this one. Now move ahead. Second is the emission of the brown fumes in the experimental setup is due to. Okay, so this is basically lead nitrate is being heated, it produces brown fumes. So this is thermal decomposition of lead nitrate. Thermal decomposition of lead nitrate, PbNO3 twice, this is lead nitrate, is being heated. Thermal decomposition, it produces lead oxide, it produces nitrogen, it produces oxygen gas, also it produces NO2 gas, nitrogen dioxide. This is brown fume. So this is our answer, NO2. First one is your answer. This one. Coming this one, manganese oxide. We have to figure out value for X, Y, and Z. It's manganese oxide reacting with X times HCl gives manganese chloride, Y times water, and Z times Cl2. Assume Z is equal to 1. In that case, we will be having only 4 chlorine atoms on the product side. These two and these two, if we assume Z is equal to 1. If we assume Z is equal to 1. So 4 chlorine atoms on the product side, definitely they must be equal to 4 chlorine atoms on the reactant side. We will be placing X is equal to 4. MnO2 plus 4 times HCl gives us MnCl2 plus, we haven't put any value for Y, it's as it is till now. Now it's Cl2 only because Z is equal to 1, we assume that. We start with balancing chlorine only. So look at this, hydrogen are 4 atoms. So hydrogen must be 4 atoms on the product side as well. So for that, we will be writing it something like this. Twice H2O plus Cl2. So we got all the values. Here we go. Moving ahead. Okay, so we have been given a table over here and we have been told to figure out which one is the correct option. Okay, lemon juice. Lemon juice turns pH paper to orange. No, incorrect. So this one is incorrect. Lemon juice cannot be basic, it's acidic in nature. Milk of magnesia. Milk of magnesia is magnesium hydroxide. That will change the pH paper to blue. pH is 10, good, basic, it's basic. Yes, we got one. Gastric juice is juice found in, or the acids found in our stomach. Mostly it is HCl. Okay, so and it is concentrated mineral acid. Its pH cannot be 6. Its pH is very less than 6, maybe 2 to 3. It changed litmus paper to red. Okay, so this part is correct, this part is incorrect. It's acidic, this is also correct, but we cannot consider it because of this incorrect information given in this column. Pure water is neutral, so no reaction with litmus paper, so it's also incorrect. We got one, that is B. This is your correct answer. A metal X is used in thermite process. We know that thermite process, what is that? That's reaction of aluminum metal with other metal oxides to get the respective metal in its pure form. So these reactions are mostly used to mend railway tracks, and also used to get metal in case of metallurgy, or we can say extraction of metals. So it says that the metal X is used in thermite process. This is a hint to identify the metal. We know that that's aluminium. When X is burned in air, so we burn this X in air, it produces amphoteric oxide, and it produces Al2O3, amphoteric aluminum trioxide. What's Y? What's X and Y? We got it. X is over here and Y is this one. Amphoteric means that reacts with both acids and bases. That's amphoteric in nature. So our answer must be this one, Al and Al2O3. Now consider the structures of the three cyclic carbon compounds, first, second, and third, given below, and select the correct option from the following. Okay, we have been given some structures. These are carbon compounds. First is a hexagon ring. So hexagon means C6. 6 carbons will be there. Each carbon is attached to two hydrogens. So that means hydrogen number is just double the carbon. It's C6H12. Cyclo. Cyclo for ring structure. Hexane. Okay, so it's single bonded. It's saturated. Now this one is first. Second, second says it's also a hexagon ring. That means carbon is C6. Each carbon is attached to one hydrogen only, so that means hydrogen is also 6. So it's having three double bonds in it also, as you can see over here, here, and here. So it's unsaturated hydrocarbon. It's popularly known as benzene. It's benzene unsaturated. Third, third is hexene, because it is having two double bonds in it. It's having two double bonds, one here, one here. So it is C6, but how many hydrogens? 2, 2, 4, 8. C6H8. It's cyclohexene. It's having two double bonds. It's unsaturated. Now the question says A, first and third are isomers. Isomer, one new term maybe for you. Isomers are the chemical compounds having same molecular formula, but different structure. Okay, so if you look at the molecular formulas given above in all the three cases, C6H12, C6H6, C6H8, so molecular formulas are different. All the three molecular formulas are different. That means, so a case of isomer can be omitted, or we can say that these are not isomers. Any option having isomer in word in it will not be your answer. Isomer, 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 no. So we can eliminate three options, first, second, and last one. So we arrived on the answer is technically or automatically. This is your answer. Okay. Sometimes it's called no look answer. Don't look at the answer. It is the answer. Moving ahead. Assertion A, the color of the aqueous solution of copper sulfate. The color of the aqueous solution of copper sulfate is blue. CuSO4 is blue in color. Turns colorless when a piece of lead is added. Lead cannot displace copper because lead is less reactive. This reaction will not happen. No product. Lead is less reactive, so cannot displace copper from copper sulfate. So this reaction will not happen. So it means that this is also incorrect. Reason is also incorrect. Okay, so option D may be your answer. A compound X is prepared. A compound X is prepared uh, from gypsum. Okay, write down gypsum first. Calcium sulfate, dihydrate. This is gypsum. And we know that we can get some compound that's called calcium sulfate hemihydrate. This one is POP, plaster of Paris. So when we add adequate amount of water to this POP, it hardens. Identify X and write the chemical formula. A compound X is prepared. So X is our POP. X is the POP. This is X. State the difference in the chemical composition between baking soda and baking powder. Good question. Baking soda is pure NaHCO3, sodium hydrogen carbonate or sodium bicarbonate. Now, what about baking powder? Powder is sodium hydrogen carbonate plus an organic acid like tartaric acid and a catalyst like cornstarch. This is a premix. All these ingredients are mixed together, and when this mixture is used in baking, so it quickly produces carbon dioxide. Okay, so there is no need to add acidic substance, and there is no need to activate it. It's already having that starch which catalyzes the reaction. But in case of NaHCO3, okay, so if you are using baking soda, you need to add a pinch of starch, or you need to add some organic acid like acetic acid or tartaric acid to activate this baking soda to produce carbon dioxide. And if you need to pick up any one of these, so go for baking soda. It's producing carbon dioxide in very large quantities and it's quick in action. Write balanced chemical equation for the reaction that occurs when blue colored copper sulfate crystal are heated. 5 times H2O is there. This is copper sulfate pentahydrate. When it is heated, it loses water. It forms CuSO4 and 5 times water is lost. So this CuSO4 is colorless and the original one is colored blue color. So it lost its blue color due to loss of water of crystallization. So color of this salt is due to water of crystallization. Sodium hydrogen carbonate is heated during cooking. Okay, so what happens to this when you heat baking soda is being heated? When baking soda is heated, it produces Na2CO3, that means it is 2 times then. So it produces carbon dioxide, produces water. So this is the thermal decomposition of sodium hydrogen carbonate. So it's baking soda This one is sodium carbonate. Now, moving to the next question, it says that identify the reducing agent in the following. Okay, so reducing agent. It's ammonia plus 5 times oxygen gives you 4 times NO and 6 times water. Look at this, ammonia to nitrogen monoxide. So it is just addition of oxygen, addition of oxygen, or it's also removal of hydrogen. Addition of oxygen is oxidation, or it's also removal of hydrogen. It's removal of, look at this, nitrogen is having 3 hydrogen atoms in the ammonia molecule, but in the product nitrogen doesn't have any hydrogen atom attached to it. That means removal of hydrogen. So it's also in this case oxidation. Ammonia has been oxidized to NO. Okay, so who does that? Oxygen. Oxygen has oxidized ammonia to NO. So oxygen is oxidizing agent and NH3 itself is a reducing agent. So this is your reducing agent. Oxygen in this case is oxidizing agent and NH3 is reducing agent. Look at second one. It's water reacting with fluorine. Fluorine molecule attack water and forms HF and HOF. So what has happened to fluorine? Fluorine has been reduced. Okay, so fluorine has been reduced by water. F2 to HF, it's addition of hydrogen, it's reduction. Who does this reduction to fluorine molecule? It's water. This is reducing agent. Then there is Fe2O3 reacting with 3 times carbon monoxide gives metal iron and 3 times carbon dioxide. You know that if you have gone through a metallurgy topic, you might have studied that when we get metal oxide after roasting or after calcination, we need to reduce that. So for that reduction, we use different reducing agents like carbon monoxide or pure carbon, that's called coke, and we can also use hydrogen. In this case, it is carbon monoxide reducing Fe2O3 to Fe. So it's reducing agent in simple terms. It's reducing agent. Now here hydrogen reacts with oxygen, produces water. So in this reaction, hydrogen gas is reducing. Reaction in terms of gain or loss of oxygen. Redox reaction that has reduction as well as oxidation reactions going on simultaneously. That those reactions are called as redox reactions. Addition of oxygen, that's oxidation, and removal of oxygen, that's reduction. Okay, moving ahead. Suggest one remedial measure each to counteract the change in pH in the human beings in following cases. Production of too much acid in stomach during, okay, so production of too much HCl in stomach can be counteracted by using, suppose, magnesium hydroxide, which is also one of the ingredient of antacid. So definitely it will neutralize it into magnesium chloride and water. So we can use antacid like magnesium hydroxide or milk of magnesia. Stung by a honeybee or nettle leaf. Stung by a honeybee or nettle leaf. Honeybee is having formic acid in it. Formic acid in it. So it can be neutralized by using basic substance, by rubbing basic substance around that stung. Next question. Fresh milk has pH of 6. When it changes into curd, will its pH increase or decrease? Okay, fresh milk has pH 6, so it's little acidic. Now, if it changed into curd, so lactic acid concentration increases. Increases. When acid concentration increases, pH decreases. So pH will decrease because pH scale starts from 0 through 7 up to 14. So this part is pH less than 7 is acidic. This is neutral and this is basic. pH greater than 7 is basic. Any pH greater than 7 is basic. Any pH less than 7 is acidic. Okay, so more acidic means more less pH, and more basic means more higher pH. Move ahead. A saturated organic compound A belongs to the homologous series of alcohols. Homologous series of alcohols. On heating A with concentrated sulfuric acid at 443 Kelvin, it forms an unsaturated compound B with a molecular mass of 28. Now, we know that alcohols like ethanol, C2H5OH, when it is be heated in presence of H2SO4, H2SO4 acts as dehydrating agent. Okay, so it is dehydration of alcohols. Dehydration of ethanol will take place, and when one water molecule from ethanol is lost, it changes into CH2 double bond CH2. This is ethene. So we got some answers over here. First, it is a saturated compound A. This is A. On heating, it produces B. This one is B. Check out the molecular mass of ethene. It's 2 times atomic mass of carbon. It's 2 times carbon plus 4 times hydrogen. So it's 28 units. Okay, so we are on the right track. Moving ahead, we have been given some conditions over here. Compound B, that's ethene. Compound B, that's ethene, CH2 double bond CH2, is being reacted with 1 mole of hydrogen gas in presence of nickel as catalyst. In presence of nickel as catalyst, what we get? We get a saturated compound C. Yes, so hydrogen will get added across the double bond. So it will convert it into CH3 single bond CH3. This is a saturated compound and it is ethane. Okay, we got it. So we have to identify A, B, and C. So A and B are already identified. So now we are identifying C, that is ethane. Write the chemical equation showing conversion of A into B. So here is your equation A to B. Then after, what happens when compound C undergoes combustion? Compound C, that means CH3 react with oxygen in that's burning. Combustion reaction will take place. Since it is a hydrocarbon, ethane having only carbon and hydrogen in it, carbon will form carbon dioxide with oxygen and hydrogen will form water. So it's carbon dioxide and water. State one industrial application of hydrogenation. So the last reaction that we discussed, this one, this is hydrogenation. This is addition of hydrogen to ethene. This is hydrogenation. So, so it's just very evident that unsaturated hydrocarbon has changed to saturated hydrocarbons. Okay. Now name the product formed when compound A reacts with sodium. Now compound A, that's our alcohol, CH3 CH2OH. When it reacts with sodium Na, it changes it into CH3 CH2ONA. This is called sodium ethoxide. This is ethanol. This is sodium ethoxide. Now, with the help of diagram, show the formation of micelle. Okay, so micelle is a structure which is formed by soaps when they encounter dirt. Okay, so say for example, this is a dirt molecule in the center, and we know that structure of soap is it's having polar head and non-polar tail. Since oil is non-polar, all the non-polar tail or all the non-polar part will bond with the oil drop, and the polar part will be away from the oil drop, because polar end is hydrophilic and tail is hydrophobic. Okay, or tail is non-polar. So non-polar will bond with non-polar and polar will bond with polar. So it's given in your textbook like this. So it will look like something this. So this is dirt. So these are polar heads. The polarity is due to either sodium or potassium positive in the soap molecule. And then there is tail part. Okay, so these are tails. Okay, these are hydrophobic and head is hydrophilic.
Dirt being non-polar is being attracted by the tails only. Okay, so dirt is non-polar. It's being attracted by the tails. Okay, so tails of the soap molecules are also non-polar in nature. Those are hydrophobic, non-polar. So in this way, the structure around oil drop or dirt particle is made by the soap molecules. This circular structure is known as micelle. So this is the diagram how you can represent micelle in your examination. So this is very important question. This can be repeated in the next examination as well. Now B part says take two test tubes X and Y. This is test tube X, test tube Y with 10 ml of hard water in each. Okay, so 10 ml of hard water. 10 ml hard water. This is also containing 10 ml hard water. Hard water means water which is having much more concentration of salt in it. That's hard water. So after that it says that in test tube X add few drops of soap, few drops of soap. In test tube Y add few drops of detergent. Now it is comparison between the action of soap and detergent in hard water. First, in which test tube formation of foam will be more and why? Okay, since formation of foam will be more in case of detergent, more foam, because detergent works well in both hard water as well as in soft waters. That is why there will be more foam in test tube Y. Second is in which test tube there is curdy solid formed. Okay, so in test tube X there is curdy solid formed, that's called as scum. Scum. So that scum is formed by the soap, because the salt in the hard water will not allow the soap to form micelle. So if micelle is not formed, that means it's not gonna work well in the hard water. So it's forming white curdy substance called scum.